Happy Monday, friends. I'm meteorologist Tim Pandages here with your Atlantic tropical update. We're watching multiple waves across the Atlantic basin, which is unusual considering we're only about 4 weeks into the season so far. We've got one that's been tagged Invest 94L that is likely soon to be Tropical Storm Bonnie. I'm going to show you why in just a second. And on top of that, Hurricane Hunter aircraft are currently in the storm as we speak. And we've got two other waves, one in the Gulf of Mexico, which we're going to talk a little bit more substantially about in just a little while. It's got a low chance of development, but there is a chance, and that may cause some issues along the southeast coast of Texas. And then out in the Atlantic basin, two separate waves emerging from the main development region that typically is not active for about another month or so when we look at hurricane climatology and where they develop and where they originate from. So very unusual to see this early on in the season. But this red area is Invest 94L. If you remember, Invest stands for Investigative Area. 94 is just a number. We rotate from 90 to 99. And the L tells us that it's in the Atlantic basin. Okay, so that's just a way to keep track of this system. There's another wave behind it. Hasn't been tagged anything yet. It's just an overall tropical wave embedded in the ITCZ, the Intertropical Convergence Zone, because these are all extremely low riders, we call them, very low latitude, and they're close to the coast of South America, which is unusual as well. In fact, northern coast of Venezuela could have some impacts from 94L as it continues to organize and develop over the coming days. So the tropics, the latest overall, three separate tropical waves that I just showed you that we're watching, one developing in the short term, and that's 94L. The next name on the list would be Bonnie. NOAA Hurricane Hunter aircraft is flying recon in the storm right now, and they just put out an update that they found tropical storm force winds in 94L. The next step on the checklist is to find a closed center of circulation. They're in the process of finding that, so by the time you watch this video, it may have been upgraded to either a potential tropical cyclone, which we saw with Alex, our first named storm of the season, that took a while to develop. And basically what that is, it allows watches and warnings to be issued for areas that may be impacted. So it may be a PTC, or they may just give it an upgrade to a tropical depression or storm. If it is a storm, it would get that name Bonnie. Overall, in the basin, which is also unusual, a little bit ahead of climatology here due to many factors, but overall the environment is very conducive. We have a lack of dry air, a lack of wind shear, and sea surface temperatures. That's a whole video in and of itself, but they are way above where they should be. In fact, 5, 6, 7 degrees above average, and each degree is that much more energy that developing tropical cyclones can use to develop and organize and strengthen. So let's start off with 94L. Development chances on these are high, both in the short term and the long term. 70% chance within 2 days, 90% chance within the next 5. Several things I want to point out here. How low its latitude is. It's south of 10 degrees north latitude, right? That's extremely low. That's a low rider there. And it is embedded in a tropical wave train known as the Intertropical Convergence Zone. And in time, this tends to lift its way back north, climatologically favored to lift its way back north. That's why the main development region becomes a little more active. And these waves are able to detach themselves from the ITCZ and go on to develop there. So we'll see if that occurs with this. It's also moving quite fast to the west at 20 miles per hour. That western trajectory is going to be maintained for the next 5 to 7 days, and there's a broad overall steering mechanism in place, which is a huge dome of high pressure here to the north that's going to steer this pretty much due west in time, and that means the Windward Islands are going to be the first land masses to deal with impacts from this as it continues to strengthen and broaden in time. So we're looking at the infrared satellite imagery here, and I also want to draw your attention to why we use this. This is a filter on the satellite imagery that depicts cloud top temperatures. And we use this particularly with tropical systems to denote where the strongest convection or thunderstorm activity is. The stronger the storms, the higher the cloud tops, meaning the colder the cloud tops are. So those are depicted by shades of black and white. That's the strongest thunderstorm activity. And this is the depicted center of 94L right now. So you can see the convection, strongest of it, is starting to centralize along that center. I also want to point out that it is nowhere near land at the moment. It is over almost 2,500 miles away from Miami, and from Barbados, just over 900 miles away. So if it's traveling at 20 miles an hour, you still got over a day, day and a half in terms of lead time to watch this thing as it evolves. Let's also take a look at a different filter on our satellite. That's the visible satellite. That's basically a bird's eye view of what the storm looks like from our satellites floating overhead. And you can certainly see an improvement in the overall satellite presentation of this system over the last few days. It has that broad spin in the atmosphere. You're seeing movement at different levels of the atmosphere with the cloud top heights, and it's certainly showing signs of organization over the last couple of days. In a close-up look, you can definitely see that spin. You got the inflow coming in from the south-southwest, and you got northeasterly winds here coming aloft. That's certainly a sign of getting its act together, and it likely will continue to do so because there's not much impeding this. We also look for a centralization of the overall spin. This is relative vorticity, atmospheric spin. And we look for circular indications here, circular features on this map to show us that there's a developing system. And this is not as spread out or broad as it was over the past few days. It's getting its act together. Even the tropical wave behind it is showing a little bit of that as well. So that is also a sign of an improving structure overall. Now, there is some dry air. That's mainly locked off to the north. And this is the season of Saharan dust. And that is certainly some of it. That is a plume that came off of the coast of Africa. It will stay to the north. One reason for that is because of how low latitude this system is. It is avoiding all of that dust. It's also avoiding the wind shear. All right, check this out. Hurricane Hunter aircraft has been forward deployed out to Barbados. This is NOAA aircraft here, and they're flying their first recon mission as we speak into 94L. And what they do is they drop instruments into the storm to get a gauge of the wind speed, pressure, wind direction, that sort of deal. And they dropped one here and they got a wind speed of 48 miles per hour. Tropical storm force winds are 39 miles per hour. So this is why they found tropical storm force winds. They are still in the system driving around or flying around in different directions to see the wind direction if there is a closed center of circulation. As of right now, they haven't found that. What's in the storm right now is a NOAA P-3 Orion aircraft. That's the plane currently in the storm, and its mission is to sample the atmosphere at low latitudes. It flies around 5,000 to 8,000 feet into the air, flies in and around the storm, dropping those instrumentation devices to get the wind speed readings, the direction, the pressure to pinpoint where that center would be. That data certainly helps increase forecast model accuracy. It goes right over to NHC, and they put it into the models. We typically can get that data in the models by the next model run. So that's how fast it relays that data and that information. So that's the good news there. In terms of the Saharan dust, here's where that is located. You saw that on the water vapor imagery, which depicted the dry air, dry, dusty air, and that's that plume coming off the coast of Africa. But here is our 94L, here's our ITCZ, void of any of that dust getting entrained into the system. And going forward, the wind shear too. So wind shear is a change in direction and speed of the wind with height. When you get wind shear, it tilts the system over and it's not able to ventilate properly. Going forward in time, the next 5 days or so, wind shear is the areas in green and blue that's high wind shear, detrimental to tropical development. You can see that forecast path here for 94L doesn't really get into any of that wind shear potentially until well into the southern Caribbean by this weekend or so, and that forecast may in fact change as it potentially heads towards Nicaragua by early next week. So again, an overall look at what wind shear does with normal hurricane flow and ventilation, inflow at the surface, outflow aloft. When you get that wind to tilt the system over, the strong wind shear, it disrupts that wind flow, that ventilation. The system's not able to breathe effectively. Let's talk about sea surface temperatures now, because overall across the entire Atlantic basin, it's hard to find any sea surface temperatures that are below average. In fact, most of the basin is well above it. But sea surface temperatures currently, where there is 94L, and you can see how warm the water is depicted by the color table here. The darker maroons are warmer waters. In fact, when we plot some of those numbers, those temperature readings, they're in the mid to upper 80s. For tropical development, the transfer of heat energy, you need 80-degree water temperature or greater. And we certainly have that, and that will not be a problem finding that further down the trail as we go forward in time with the development of 94L into Bonnie. Also to note here is that warm water is not just on the skin of the ocean, it extends down to a depth. Ocean heat content here, especially where it's located, where it's heading, goes down to a depth. And why that's important is because when these storms develop and they become stronger, they create waves with the wind that they generate. The waves mix up the ocean, something called upwelling. So if you have the warm water just on the skin of the ocean, when you get the upwelling, it will mix up cooler waters from the depth, and it's self-limiting and it will peter on out. When you've got warm water extending down, you're upwelling continuously warm water, so you're sustaining itself in terms of heat energy. Here's a look at the sea surface temperature anomaly. So the departure from average, what we see on a normal basis, what the temperature should be in the Atlantic Basin based off of 30 years of data. And you've got the oranges here that are almost off the scale in terms of how warm and how far above normal these temperatures are. And this area here, I can just draw it in. You kind of see a big old rectangle. That is called the main development region, and water temperatures there are just cooking. And even more above average is the Gulf of Mexico, especially the northern Gulf of Mexico that has those sea surface temperatures in the low 90s. So what do the computer models see 94L as doing? So we're looking at the GFS ensemble. What the ensemble is a member. There's 30 of them. It's the GFS model run. We tweak it ever so slightly to try to get a different outcome. And we're not seeing much spread. Notice there's a lot of consistency here several days out, which is unusual at times for tropical systems. A lot of times you'll see members spread out over a large area. They're very much confined and pushing it off to the west. So a good consensus on the GFS ensemble this run that it heads west over the next 5 to 6 to 7 days and potentially impacts Nicaragua either as a weakening system or taking advantage of the overall conducive environment in the southern Caribbean and developing into a system that really needs to be watched. So this is something we're going to monitor very closely. Let's get a little view now of what's going on in terms of the geography in the Windward and Leeward Islands. We've got all of these islands that are likely going to be the first areas to experience impacts from 94L, especially the southern Leeward Islands and Windward Islands as that system draws closer over the coming days. All right, now let's compare the models. We just looked at the GFS ensemble. Now we'll look at the GFS operational model compared with the European operational model. And what you're going to see here is the red lines is going to be what the European model sees the atmosphere is doing. The yellow lines is going to be the GFS or the American model. They both go out long range, so we'll take it all the way through next week and see what we get here. So here we go. We've got a broad system now. By tomorrow night, starting to organize a little bit better, but very low latitude and brushing the northern coast of Venezuela. Now, if in fact the center of this system was to go over northern Venezuela, interaction with land is always detrimental to tropical systems. The main reason being is because it's away from its fuel source, the warm ocean water. So if this was to drift over land, there's Trinidad and Tobago right there, it would impede its development and strengthening. So that'd be a good thing, and it would bring a lot of rainfall here in northern Venezuela too. Scoots the northern coast there. Both models are pretty much consistent in showing that exact same thing. The only difference is a little bit faster. The European takes it farther west, and GFS kind of hangs back to the east a little while longer. Same general trajectory. And then here's the bigger difference. Here we are Saturday afternoon. The European shows nothing. It falls apart with the European model's solution of what it thinks it will happen in the atmosphere going forward this run. Then we've got the GFS that says, you know what, we've got the warm ocean water. It goes down to a depth. We don't have any dry air. And wind shear will be a factor, but probably not so much. So we're going to strengthen this system significantly and show it as a bona fide hurricane at this point, just before it potentially makes landfall along the east coast of Nicaragua. This is something to watch. Still got tons of time to watch it, 5 to 6 days, but this is what it's been showing for the past several runs, a due west trajectory into Nicaragua and then interacting with land and falling apart quickly thereafter. So the next name, as I talked about, Bonnie is up on the list there. We've got those two other waves out there as well, so we could either have Colin and Danielle potentially all within the next week and a half or so. Unlikely we see all three at the same time, but most likely we definitely have Bonnie. Let's talk about that area in the Gulf of Mexico now and what the overall setup is with that. This is a decaying front that's dropping its way from Texas down into the northern Gulf of Mexico. The reason why this is going to likely spin off some sort of tropical development is because it's really hard to get a cold front to drop this far south this late in the season. They typically stay well to the north. So that broad area of low pressure along a decaying front is enough to spin up an area of low pressure. That area of low pressure quickly takes advantage of the warm sea surface temperatures, and you start to see some general broad development here. As it moves to Tuesday, we see a weak boundary, a stationary boundary develop along the northern side of it. That brings spotty storms up and inland. And then notice you can see the broad circulation developing here by midweek as that storm system's really starting to gather itself and use that fuel to produce a more organized system. Here's how it looks on the modeling. You can see that broad spin sitting over those 90-degree water ocean temperatures. NHC says 10% chance within 48 hours, 20% within 5 days. If in fact something was to develop here, it would be on the weak side and it would be brief, because then it's going to quickly move inland and fall apart as it interacts with land. We had a lot to talk about. We covered a lot in this video. And until next time, if you have any questions on this stuff, I love talking about tropical weather. You can find me on Twitter, Instagram, or on Facebook. I'll see you again tomorrow with an update. We'll likely be talking about Bonnie as a named tropical storm at that point in time. And we'll watch what happens in the Gulf of Mexico as well. Until then, enjoy the rest of your Monday.